Okay, so get this. We're diving into autoregressive image generation, guided by chains of thought.
Oh, this is a good one.
It is, right? This paper is all about how to make autoregressive image generation smarter.
Smarter and more reliable.
Yeah, more reliable, exactly. And they use something called chain of thought prompting.
I'm sure our listeners have heard of that.
Yeah, probably. But it's usually used for like NLP tasks.
Right.
But this paper found a way to apply it to images, and they got some really impressive results.
Like a 20% improvement in FID scores?
Yeah, which is like a huge E-jump.
Huge. Compared to a regular autoregressive model.
Exactly. And the cool thing is they didn't just stop there. They tried different types of reasoning prompts.
Like class reasoning prompts.
Yeah, for specific categories, and then universal reasoning prompts.
For, for a broader approach.
Or general, yeah.
Basically, they figured out how to take these reasoning techniques we use in NLP and apply them to visual generation.
It's pretty mind-blowing.
It is. It really is. This paper really stood out to me. Autoregressive models, they're getting better all the time.
They're getting closer to diffusion models.
Exactly. Closer to diffusion models, but they still struggle sometimes, especially with complex structures.
Yeah, details, yeah.
Yeah, all those fine details.
Well, maybe just for anyone who needs a refresher, can you quickly explain how autoregressive image generation works?
Sure. So autoregressive, or AR for short,
Right.
AR models, they work by predicting pixels one by one.
By one, okay.
Based on the pixels that came before it.
So it's kind of like predicting the next word in a sentence.
Exactly. But with pixels instead of words.
Okay, I get it.
But here's the thing, and this is where the paper gets really interesting.
Okay, tell me.
This whole next token prediction thing works great for NLP, but it might not be how we humans actually see images.
You mean like when we look at an image, we don't just see one pixel at a time?
No, we see the whole thing. We understand, like, how the objects relate to each other.
And the context of the scene, right?
Exactly. We use our knowledge of the world to make sense of it all.
Makes sense. So that's where chain of thought prompting comes in.
Exactly.
So how does that work with images?
Well, imagine like giving the model a set of clues to help it reason through the image generation process.
So instead of just guessing the next pixel, it has some guidance.
Right. It can consider the bigger picture.
That makes a lot of sense.
And that's why the paper says that that AR image generation is actually a really good fit for Coty prompting. Because
of that step-by-step process.
Yes, exactly.
Cool. So tell me about the author's proposal. Image generation with thoughtful reasoning.
IGTR.
IGTR, right. How does it actually work in practice?
Well, one thing I really like about IGTR is that, it doesn't change the model itself.
You mean the underlying architecture?
Yeah, the structure. They just introduce these reasoning prompts.
Without changing how images are generated.
Exactly.
So it's easy to implement.
Very easy to implement.
That's great.
But the magic, the magic is really in the prompts themselves.
Oh, okay. So what are those prompts like?
They basically give the model a sense of like the overall image before it starts generating pixels.
So it gets a sneak peek at the style.
Yes, the style, the theme.
Before it has to fill in the details.
Exactly. It's kind of like, giving it a framework to work with.
That's cool. And the paper, it talks about how this affects both training and inference, right?
Yes. During training, it helps the model converge faster.
So it learns more efficiently.
Yes, learns more efficiently. And then during inference, it helps with stability.
So you're less likely to get those weird, nonsensical images that sometimes come out of AI models.
Exactly. Less likely to get those weird results.
Now, you mentioned two types of reasoning prompts.
Right.
Class reasoning prompts and universal reasoning prompts.
Yep.
What's the difference between the two?
So class reasoning prompts, they're specific to a certain category of images.
Like cats?
Yeah, like cats. So if you're training a model to generate cat pictures...
You'd use prompts about cats.
Exactly. Stuff about their anatomy, their poses, the usual backgrounds you see cats in.
It's like giving the model a specialized cat vocabulary.
That's a great way to put it. Universal reasoning prompts, on the other hand. Those are more general. They're about broader patterns you see across lots of different images.
Okay, so it's like teaching the model about composition, maybe.
Yes, composition, color palettes, things like that.
So did they test these prompts out? Like see how they actually performed?
Oh yeah, they did a bunch of experiments.
Cool, tell me about it.
So they used the ImageNet data set.
Oh, classic ImageNet.
256 by 256 resolution.
Okay.
And they mainly focused on the FID score.
The FID score, right?
Lower is better.
Got it. And they use different model architectures.
Yes, based on llama.
Yes.
B, L, XL, and XX.
So a range of sizes.
For a range of sizes.
Yep. Did IGTR actually work?
It did. It consistently beat the baseline LlamaGen model, no matter what prompt they used or what size model.
That's pretty impressive.
It is. Although they did find that the class reasoning prompts, they usually did better than the universal ones.
That makes sense to me. Like, if you give the model more specific knowledge about a topic, it'll perform better.
Right, like studying for a test, you know what to focus on, you're more likely to do well.
Exactly. What about those robustness experiments?
Oh, yeah. Those were cool. They wanted to see what happened if the prompts weren't consistent.
You mean, like, if the prompts during training were different from the prompts during inference?
Yes, exactly. And guess what?
Did it still work?
It still outperformed the baseline.
Wow, that's really robust then.
Very robust.
So what about prompt length? Did they experiment with that?
They did. They tried different numbers of tokens in the prompts.
Huh.
Longer prompts generally did better.
Okay, so the more information you give the model, the better it performs.
Up to a point. There's a sweet spot.
Mm-hmm.
You know, you don't want to overload it.
That makes sense.
And they also found that the timing of the prompts was important.
Timing, how so?
Well, if they gave the reasoning prompts after the image was generated,
Oh, interesting.
it didn't really help.
So the model needs that guidance up front
It does.
to kind of bake that reasoning into the process.
Exactly.
Now, let's talk about the computational resources involved.
Okay.
I mean, AI image generation can be pretty resource intensive.
Well-
Did the authors address that at all?
They did. They did this clever thing with what they called blank prompts.
Blank prompts. What's that?
Just prompts filled with meaningless tokens.
Okay.
Basically just to see what the impact of extra computation was.
Interesting. So what did they find?
Well, the blank prompts, they didn't really improve the results.
So it's not just about giving the model more to process.
No.
It's about giving it meaningful information.
Exactly. The content of those prompts really matters.
Okay, let's switch gears a bit and talk about classifier-free guidance, or CFG.
Okay.
The paper mentioned they experimented with different CFG settings. What role does CFG play in all of this?
So think of CFG as a way to control the balance between creativity and realism.
Okay.
Higher CFG settings, they tend to lead to more realistic images.
But maybe less diverse.
Yeah, potentially less diverse.
So it's a trade-off.
It's a trade-off, exactly.
Interesting. And I know we've been talking a lot about theory, but can we see some examples of what IGTR can actually do?
Oh, of course. Here's some images generated by IGTR, trained on the ImageNet dataset. You can see they're pretty diverse.
Wow, these are amazing. The level of detail is really impressive.
It is.
Okay, last question. What about scalability? How does IGTR perform with larger models?
Well, that's what's really promising. They found that IGTR actually scaled quite well. Larger models led to better FID scores.
Okay, so it's a robust approach that can handle more complex models.
Exactly. And that's really encouraging for the future of this research.
This has been a fascinating dive into IGTR. We're just getting started, though. Come back for part 2, where we'll dig into the broader implications of this research and where it might be headed in the future.
So before the break, we were looking at some of those IGTR images.
Yeah, those were pretty cool. I mean, it's amazing what AI can generate these days. But beyond the pictures themselves, what do you think this research means for the field, like the bigger picture?
Well, I think it shows, that we can really make progress by borrowing ideas from other areas of AI.
Like NLP in this case.
Exactly. NLP. And using them for visual generation. It's like, cross-pollination between different fields.
Yeah, it's a good reminder to stay open-minded. You never know where the next breakthrough is going to come from.
Exactly. Keep those eyes peeled. Was there anything else in the paper that we haven't talked about yet?
Oh, yeah. They talked about this idea of, thought complexity.
Oh, right.
They found that prompts that encouraged more elaborate reasoning, well, they tended to lead to better results.
Yeah, it's like you don't just want to give the model instructions.
Right.
You want to encourage it to think deeply.
So more strategic thinking.
Exactly. Like instead of giving someone a recipe, you teach them the principles of cooking.
Oh, I like that.
Yeah.
So they can apply that knowledge in different situations.
Yes. And I think this research, it really gets at, the heart of what we're trying to do with AI.
You mean like building systems that can actually reason?
Yes. Not just follow instructions.
It's a big challenge. The authors also mentioned the limitations of current evaluation metrics.
yes.
Like the FID score and Inception score. You're useful.
They're helpful, but they don't capture everything.
Right. Like they don't really tell us how humans perceive the images.
Or how aesthetically pleasing they are. It's a tough problem to solve.
It is. It's like, how do you measure something that's so subjective?
It's subjective, exactly. But I think we need to keep working on it, especially as these AI models get more sophisticated.
Absolutely. I mean, that's the whole point, right?
Yeah.
To understand our own intelligence better.
To understand and augment our own intelligence. Now, I wanted to talk about something that the authors didn't really address in the paper.
Okay.
But I think it's really important to consider.
I'm listening.
The potential impact of all of the, these techniques on creative industries.
Oh, yeah, that's a big one.
It is, right. Imagine, anyone can use AI to generate high-quality images.
With just a few prompts.
Yeah, regardless of their artistic skills.
That's pretty wild to think about. I mean, it could be really empowering.
It could be empowering.
For people to express their creativity. But it also makes you wonder about the role of human artists.
It does, and it raises questions about, what we value in art, like originality.
And skill.
Yes.
And it's not just art, right?
No, not at all.
This could change advertising.
Advertising, design, entertainment.
I mean, imagine generating custom product images.
Or marketing materials, tailored to specific people.
It's crazy. And what about the visual effects in movies and video games?
Oh, yeah. They could become even more realistic.
More immersive. But, with all these possibilities, there are also potential downsides.
Of course. We have to think about the impact on jobs.
And copyright laws.
And even our understanding of what it means to be creative.
Like, what does it mean to be creative if a machine can do it too?
It's a deep question. I think it's crucial to have these conversations, about the ethics of all this.
As AI gets more powerful.
Yeah, as AI gets more powerful and more accessible.
I'm glad we're talking about this. It's something I've been thinking about a lot lately. What are some other research directions, do you think, that might stem from this work?
Well, I think it'll be interesting to see if we can personalize these reasoning prompts.
Oh.
Like, what if the AI could understand your individual artistic preferences?
And generate images based on that.
Exactly, like having a personal AI art assistant.
That would be so cool.
It would be. And it doesn't have to stop at static images either.
Brilliant.
Like, could we extend this to video generation?
Oh, wow.
Or even interactive experiences, where the user can give feedback in real time?
That's mind-blowing. It's like a true collaboration between humans and AI.
Yeah.
Yeah.
But of course, as we explore all these possibilities, we have to keep ethical implications in mind.
Right, like bias in the data.
Bias, misinformation, copyright issues.
It's a lot to consider.
It is. We need to make sure that these technologies are used responsibly.
For good, not for bad.
Exactly. It's a balancing act. Fostering innovation while also protecting people.
This has been a really thought-provoking conversation.
It has.
I feel like we've only just scratched the surface of what this research could lead to.
Yeah, this is just the beginning.
We've talked about the technical details of IGTR, the impact on creative industries, and the ethical considerations. We'll be back in part 3 to wrap things up and share some final thoughts on this groundbreaking research. So, we've spent this whole deep dive exploring this paper, Autoregressive Image Generation, Guided by Chains of Thought. And I gotta say, it's really got me thinking about the future of AI and creativity.
Yeah, it's a fascinating paper, isn't it? I mean, we've covered a lot of ground. The technical details, the potential impact on art, and all the ethical questions it raises.
Exactly. So as we wrap up, I'm curious, where do we go from here? What are some of the big unanswered questions or like the next steps in this research?
Well, one thing that I'd love to see is, how these reasoning prompts could be used for other things, not just images.
Well, like what?
I'm talking video generation, 3D modeling, even music composition.
Wow, that would be incredible. Applying those same principles, but to totally different creative fields.
Right. Imagine AI that can compose music as good as a human, or choreograph dances, guided by these thoughtful prompts.
It's almost like the AI becomes a partner in the creative process.
Exactly. And then it makes you wonder, what does it even mean to be creative anymore? If an AI can do all this, what's the role of the human artist?
That's a big question. This research really challenges our assumptions about creativity.
It does, and I think we need to be thinking about the impact on the creative industries as well.
Yeah, like if anyone can create professional quality art or design using AI.
It could be incredibly empowering, democratizing creativity, but what happens to the artists who make a living from their skills?
Right. It's a double-edged sword.
It is. And we also have to be mindful of the potential for misuse.
Oh yeah, like using AI to create deepfakes or spread misinformation.
Exactly. We need some ethical guidelines and some safeguards to make sure these tools are used responsibly.
For good, not for evil. So, beyond the ethical stuff, what are some of the technical challenges you see?
Well, we need better evaluation metrics. Like right now, we have things like the FID score, but those don't tell us everything about how humans perceive an image.
So we need metrics that go beyond just measuring how realistic something looks.
Exactly. And as these models get more complex, we need to be able to understand how they actually work.
Right, so they're not just these mysterious black boxes.
Yeah, we need to be able to interpret their decision-making processes if we're going to trust them.
This whole field is moving so fast, it's hard to keep up with all the new advancements.
Yeah, it is. But it's exciting. It's a really fascinating time to be working in this area.
Well, thanks for taking us on this deep dive. It's been a really thought-provoking conversation.
My pleasure.
And for our listeners, this paper is just the tip of the iceberg. There's so much more to explore out there. Keep learning, keep experimenting, and keep asking the big questions.